Hello everybody, my name is Donald Harkness. I'm going to talk to you about spipgm2. So what is spipgm2? Pretty complicated name, right? Well, it's a simple program. It runs on DOS. You typically put it on your floppy drive or in a bootable hard drive, depending on your choice. And once you boot it into DOS via your floppy drive or your hard drive, you would use this program to reflash a BIOS chip via your parallel port. So typically you'd need a computer that's already working and a chip that's got a bad flash on it, right? So if your computer is suffering from the problem where you can't boot into the computer at all because your flash is destroyed by a bad flash update or something, then this is what you need to use. The reason why you need to use this is because if you're using another computer to update your flash, you're going to have a lot of problems trying to update your flash if you can't put your chip into the other computer. So why would you want to use a parallel port? Simply because you can do it from any other computer, right? So you take your chip out of your computer, go to another computer, and you would connect this chip up via a circuit, which I'll be showing you just now, and then boot into DOS, and from DOS you would run spipgm2, and then use that to reflash your BIOS. So exactly how does it work? First I'm going to show you the circuit diagram which I drew up. The heading spipgm2 successfully verified experimentally. This is what worked for me, and I've compiled it for you in a little circuit diagram. It's not very complicated. This is your BIOS chip. That's the indentation that shows you the BIOS chip orientation. Okay, that's the parallel port, and the rest of it's basically the circuit diagram. The positive and negative terminal here represents a 4.7 volt DC battery. The reason why I use a DC battery, I got the DC battery out of a cell phone, alright, but you can get it from anywhere. The reason why I used it is basically to keep the voltage very smooth. I found that worked better, right? And then you need a capacitor to keep the voltage stable as well. I didn't test it without the capacitor, but I got it to work with a 1000 microfarad capacitor. So that's basically your input, the capacitor and the battery. And then you would connect it up to the BIOS chip as seen here. This red wiring here is actually wiring. It means that you're connecting this pin, and that pin together, right? And then connecting it to the positive terminal of your input. All right, so now the negative terminal is connected to the ground, right? This is your ground, basically, and then that connects to that point on your parallel port. So outside of the inputs, you've got another 4 wires, each with a variable resistor. Okay, I had variable resistors, but you can try just putting a 250 ohm resistor on each one, because I was testing the resistance to find the most reliable resistance, and I found it to be 250 ohm. So you got 4 250 ohm resistors, you got your 4 inputs, and that's basically connected to the BIOS chip at these positions here. Just make sure your parallel port is orientated the way it's orientated on the diagram. Alright, 4.7 volt DC battery, 1000 microfarad capacitor, and if you want to use variable resistors, I recommend that, because if it doesn't work on 250 ohm, you can connect it up with some clips so that you can unhook it and retest the resistance using the variable resistors. Alright, so it's not that complicated, very simple diagram. Try to solder all the joints properly so that you don't get problems, because I actually wasted a lot of time on that. And try to get a little slot to plug your chip into, because you might be unplugging it to test it and then it won't work and you'll have to plug it in and so on. Okay. So that's the diagram. You can reference the diagram from the video as seen here, or you can visit the link below and visit my website where I'll be posting this diagram and you can download it. So let me show you something else. If you want to get the program spipgm2, it's pretty simple. You go to your browser, alright, and in the search box you type spipgm2 space download. I think that's the easiest way. And you'll find it. This is it here. spipgm2.exe.ra-argos-file sharing. I don't know if this will still be up by the time you get to my video, but if you can't find it here, search around for it elsewhere. It should be somewhere. But this is the easiest way to get to it at this present moment. So you go in there. Okay. You just have to click these little pop-ups away. And then you'll see the RAR. I'll click on the download. I suppose it will be the same as that, but I clicked on the download, and it's a very quick download because it's a small little zip file. So once it's downloaded, you'll go and you'll put it where you need to put it. So I'm going to put it on my desktop, create a new folder. Alright. I'm going to call it spipgm2. Paste that in the folder. And then extract it. Now what it'll give you, you don't need to worry about obviously you don't need to worry about that. That's just the RAR file. But if you look at those three, this is just a little guide. So it's these two files that you need to put on the floppy disk or on the DOS partition that you're going to be booting into. The one is CWSDPMI and the other one is spipgm2. This is an exe. Okay, so that is the files that you need, and the wiring diagram you can get either by referencing the video or going to the link below.
Alright, before I go into DOS, what I've done is within Windows I've created my boot disk by right-clicking on the drive and formatting a DOS boot floppy. Alright, and these are the files that I put in there. spipgm2 consists of those two files there. Obviously that file and CWSDPMI. And then that is my bin file for my BIOS. It's going to be going onto that chip there. Now what I intend to do is I'll just rename it flash.rom so that I don't have to keep looking up different names. Okay, so I'm going to rename this flash.rom, reboot into DOS, and so what I've done is I've gone into the hex editor and I'm reading the ROM file from the hex editor, and I'm going to write down some of this so that I can actually see when it's done a good flash later on. When you boot the machine up, you've got to make sure that your parallel port is set bidirectional, and you have to make sure that it's set to 378H LPT1. Okay, so I'm just going to reset and show you that. So I'm in my CMOS now, I found it here. Maybe I integrated peripherals now. There are onboard super input output devices. There you can see parallel port mode. One's on SPP and it worked. 378/RQ7, that works. So yeah, you might need to play around with that, but that's definitely something you need to look at. Make sure that you're going to be booting from DOS by going through your settings. Okay, so 1.44 megabyte. Cloud A. Go through your boot order. Make sure that it's booting first boot device, cloud A or removable. Okay, removable in our case. And when you're done with that, so usually if you've changed something you can save an exit. If you haven't, you can save an exit as well, it doesn't matter. The machine always reboots when you exit the BIOS settings menu because yeah, whether you save or not, it reboots. Okay, so it's booting into the A drive. If you saw how I set that boot up, you can also, like I say, do it in on a hard drive. You can just download a DOS boot CD install. Try to install the simplest install possible, and then you can boot from the hard drive. Right. It's either way. The A drive is easier because you can run you don't have to wipe out your operating system if you haven't got an extra drive. Okay, so let's see what we got here. Okay, so that's just the DOS command prompt, and there's your two spipgm2 files just below that, and there's my flash.rom. That's just a convention I'm using, so that I don't have to wonder what the actual numbers are on the name. Okay, so down at the bottom here, what you do is you go, okay, so here's the circuit here. I have shown you the diagram. The circuit is exactly the same. It's got 250 ohms on each of these, all of them the same. Alright. And there's a 4.7 volt supply coming from this. Alright. And it's currently switched off. Okay. I only switch it on when just before I need to use it, so I don't run the battery for that. The negative is connected permanently, but the positive is on the switch. Okay. That's basically it. And then some interesting things here. These pots have been stuck down with double-sided tape or mirror tape, and I've used crocodile clips so that I can disconnect them and set the pots. It helps to have something to slot the chip into. That thing doesn't cost very much at all if you can get to an electronics shop, and it will make your life a lot easier. Okay, so now, like I say, I'm ready to do some testing with the flashing of this device. And there's the switch. Everything is ready. Alright, so all I do is, just before I want to do some work on it, I'll switch it on. Okay. And then I can actually go through the process. Now the first thing I do is I identify it. It's a weird naming convention. I always think of it as SPIP, then GM2. It's easy to remember. Then /I is to identify. So the first thing you do is identify. You want to see something positive on the identifier, like that is positive. It's not a whole lot of F's or whatever, and it looks like something that makes sense. But I've written down what I'm expecting to see there on a previous flash. Whenever it seems to be successful, semi-successful, I'll get that result, EF4014H.
See, I've written it down from previous attempts. You see. Okay,
so basically, so far it looks good. So what I'll do is, you can read it now if you want, but it's not totally necessary. spipgm2 /read. You always go north by, and basically, from my notes that I took, it makes more sense for me to read 0002D800, because that's where things started to happen from the BIOS file that I was looking at in Windows. So if you come here, you want to type 2D800. Well, my specific case would be that 2D800. Okay. I'm just looking for 5 digits there. Okay, and space. Then you go north X, and then you just type how many lines you want to look at. So I always type, say 100 or something. And this will show you what's on it at the moment. You can see it's all F's. Out. All F's. So that'll be something to compare it with. Okay, so now what I'm going to do is I'm going to unlock the device. So it's very important to unlock it. Otherwise it won't work. Unlock /U. And if it successfully unlocks, the device is unlocked now, then you know you're going, things are working out. Okay. Okay, so after I've unlocked it, then I'll type the same command again, spipgm2 /. Now it's unlocked. I'm going to erase it first. With the E /E. It doesn't take very long. It says done. You can confirm it with the read again to check that it's done the erase. Not much point because there's F's everywhere anyway, so I'll trust that it's done that. Okay. Now, I don't know if it's totally necessary, but I'll unlock it again before I actually do the flash. Very important to unlock before you try and do anything. So just as a convention, I'll just unlock it just before I do the actual flash. Unlock. Yeah. Now I managed to get a successful flash using the P command. So I'll first try the same method with this chip, and if it doesn't work then I'll use the S /S for slow. Okay. So this is the fast method. I like to always repeat something if it works or has worked. /P for program, and then /long, because that's the name of the file in my program. And it's just like that. So spipgm2 /P/long after unlocking and erasing. Okay. Just unlock it out there. Okay. So we enter. Now it always seems to be asking me for this particular chip what the size is, and it says wooden bond unknown chip, so that's probably why I'm having trouble. Maybe it doesn't know what chip it is, but anyway. As far as I know, the chip is 1024, but I did see it coming across as 1048 for some reason. So just to be on the safe side, I'll type 1048. I don't think it'll make any difference if it's slightly more. Okay, so that's the size of the chip, and it goes through the process of supposedly writing to it. So effectively it's busy flashing this here, coming from the parallel port behind there. I actually soldered the parallel port wires internally, or tried to actually, and it didn't work, and then I found a way of hooking it in. If you can even see it. Anyway, what I did is I took some paper clips and bent them, and I found a way to sort of hook them in at the back. And that worked pretty well. Basically, you can sort of test with a multimeter if you want, but it's actually quite easy to figure out because they in the same. They go from top to bottom the same way the pins do on the front side. Okay. But the earth I had to do from the back because I could only see the 4 wires that the resistors connect to. From the back, and I only had to connect one pin on the other side. You can use an LPT cable as well, but I didn't have an LPT cable handy, so I had to do it this way. And anyway, this is very important because if it's not stable by the connectors here, then you're going to have problems. It's very important to solder all your joints. I tried to do a quick job without soldering and I just ended up with all sorts of trouble. So very important to keep it neat and tidy and solder everything properly and test with a multimeter while you're building the circuit so that you know there's no problems, because to try and find a problem later is going to be a nightmare. Okay, so you can see there it came up with some kind of error. It cannot read page 4096 from file. That's probably because I typed it in too large. Okay, so that's fine. It shouldn't be a problem. It's probably flashed quite a bit anyway. Let's check that 0002D800 and see what happens. So. /read 0x, and I'm going to the 800 according to my notes, and this here is always the same, 100 or whatever. You can do 50 if you want. Let's see what happens. It looks like it made any sense. So if I compare it with my notes, I'm looking for 2 rows of S, and then this number must be 44, and then those must be zeros. Then I've got 90, 9E, 0394. The first line is the same as what I've written down here, so that's a very good sign. Excellent sign. Okay, try it. It's booting. I don't believe it. CMOS settings wrong. Oh, that's not a big deal. So there you see, it worked. I have got my computer back. Press F2 or delete to run setup. So we'll go and run setup. And there you have it. I rescued my computer from hell with this device over here. So it's confirmed on 2 chips it worked perfectly with 250 ohm, 4.7 volt battery power supply, a 1000 microfarad capacitor, and the circuit you've seen. So you just follow that circuit and these values that I'm mentioning here, and all's going to work.